Hi, my name is Tatum Hardy, and this is Lab 1. In this lab, we'll be determining the amount of charge on one strip of tape, the number of electrons on one strip of tape, and the number of atoms on one strip of tape. The results are as follows. The sections of this lab include defining the experiment, the physics connection, balancing gravitational and electrical forces, calculations with Python, determining the charge on one strip of tape and the number of electrons on one strip of tape, and finally, determining the total number of atoms on one strip of tape. This experiment required you to make a charged piece of tape. To achieve this, you must stick a strip of tape approximately 20 centimeters onto a smooth surface. This will be your base tape. Then firmly stick another piece of U-tape on top of the base tape. Quickly remove the top piece of tape from the base tape, which remains on the smooth surface. Hang the U-tape vertically from the edge of a table and bring your hand near the table. Notice that the tape is attracted to your hand. So what would happen in an interaction between two U-tapes? Well, they would end up repelling each other. This is because when two neutral pieces of tape are stuck together as they were in the first couple of steps in the experiment and then rapidly pulled apart, each piece of tape is left with a non-zero net charge, even though the E net of both pieces of tape together is still zero. This suggests that after separation, each piece of tape has a non-zero net charge of the same magnitude, where one piece of tape carries the negative charge and the other piece of tape carries the positive charge. If you would repeat the same process under the same conditions, you would almost definitely yield the same result. So if you had your two U-tapes interact, they would be carrying the same type of charge, whether it be positive or negative, as well as the same magnitude of charge, so they would repel each other. That being said, if one of the U-tapes was to interact with a negatively charged object, like a plastic pen, and the U-tape was carrying a positive charge, it would be attracted to that object. If the tape was negative, then the U-tape and the plastic pen would repel each other since they carried the same type of charge. After having the U-tape interact with an object known to have a negative charge, it can be determined that the U-tape carries a positive charge. How should a neutral U-tape interact with a charged plastic pen? The neutral U-tape interacts with the plastic pen in the same way that your hand interacted with the U-tape hanging off the side of the table. It creates an induced dipole. This means that the charges within the neutral object, in this case the U-tape, rearrange themselves on the surface of the object so that the like charges repel and vice versa. In this example, this would be the reconfiguration of the U-tape in the charged plastic pen. In order to balance the gravitational electrical forces, you must fix one of the U-tapes in between two poles or surfaces so that the middle portion of tape B, in this case, is hanging. Now once you introduce tape A, tape B will begin to float a certain distance B above its original hanging position as demonstrated by figure 3. For my experiment, this distance was 5 millimeters. Tape B reaches a new equilibrium position where the gravitational force and the electrical force due to the tape compose the action and reaction forces. Since the momentum of tape B is not changing, then you can conclude that the net y component of the force on tape B is 0 based on the force equation where momentum is 0. The free body diagram on this situation would be as follows. I used Python to find all sorts of quantities. Specifically, the electrical force quantity. In this scenario, instead of saying that the electrical force quantity was simply the negative of the gravitational force quantity, I calculated electrical force by first calculating electrical field. Nevertheless, you can calculate electric charge from the force of gravity if you assume that the force of gravity equals the negative electric force. In order to calculate gravity, you'll need the mass of the tape, which is equal to 1 gram per 1 meter. From there, you just calculate gravity, Fg equals mg. To calculate Q sub b, we'll be using the concept located in the fourth equation, that is the magnitude of the electric field, force. Once you reorganize the equation, you algebraically solve for Q sub b. To determine the number of electrons present, you simply divide your Q sub b by the elementary charge. So the total charge on a piece of tape is 2.39 times 10 to the negative 9th coulombs, and the total number of electrons on a piece of tape is 1.49 times 10 to the 10th electrons. In order to find the total number of atoms on each piece of tape, you simply divide each of the dimensions of the tape by the approximate length scale of an atom. The total number of atoms in my experiment was 2.3 times 10 to the 9th. To conclude, let's answer a couple of questions. Firstly, if electrons carried a positive charge, the results of the experiment would be flipped, all except for when two pieces of tape interacted with each other. And it's important to handle the charged tape as little as possible so that your neutral body does not transfer the non-zero charge of the tape off of the tape through your body into the ground. Thank you so much for listening. This was Lab 1.